I started work on building the different planets of my sci-fi series and got to thinking about what a planet really is. What minimum requirements do my planets need to be considered planets, and why? Hi, I'm Casey Hudson and I write sci-fi novels. Today, I'm trying to figure out if all the species in my Drifting Amalgams universe live on planets. Here's what I've learned about what constitutes a planet. Until 2006, planets were just concepts. But in the magical year that Pluto was declared not a planet, the International Astronomical Union formally decided that for an object to be a planet, it must orbit the sun, be big enough to have enough gravity to force it into a spherical shape, and be big enough that its gravity has cleared away any other objects of a similar size near its orbit around its star. Scientific debate continues, though, and human understanding of the universe evolves, so this definition may change. Realistically, this definition isn't quite so clear, because non-satellites that meet the first two criteria are still planets, semantically speaking, but they get the special designation of dwarf. Dwarf planets include Pluto, as well as some others, and those of you who dissected the first criteria probably noticed the phrase, must orbit the sun. Because yeah, that definition is just for our solar system. For exoplanets, meaning planets outside of our solar system, the definition is vague. So for someone like me who's creating planets that aren't in our solar system, world-building sci-fi planets is tricky. How do I build a planet if I don't even really know what one is? Fortunately, astroscience and geoscience each have an interest in formulating and sharing a definition of planet. Geoscientists especially are looking at things like landforms and distribution of the world's mass. According to the Planetary Society, mass is the foundation of a reasonable definition for a planet. Essentially, geologically significant worlds are not massive enough to have fused atoms, let alone nuclear fusion, like stars do. But they are more massive than non-planets like asteroids. Being more massive means that instead of being composed of rubble and void space, a geologically significant world crushes itself under its own weight. And more mass means more self-gravity, which results in a rounder object. In terms of size, the smallest round worlds discovered have been roughly 400 kilometers across. Being round allows worlds to have enough gravity to keep an atmosphere in place and to have internal heat that drives volcanism and tectonics. I like the idea that my species grew up in a natural, meaning not artificial atmosphere, so it sounds like they live on a round object at least 400 kilometers across. I may still want to have people living on non-planets though, so I have to remember that a backstory of how they made that environment livable is necessary. And for my sci-fi planets with more mass than Earth, I can play around with magnetic fields because more massive planets tend to have powerful magnetic fields due to the nature of their formation. Using a geophysical perspective, it looks like I can have planets, which are gas giants, ice giants, terrestrial bodies, including the Moon, and dwarf and satellite planets, as well as super-Earths and sub-Neptunes, which are found in exoplanetary systems. Sounds like sci-fi writers have a lot of choices that can be made when tailoring their planets to their species, or vice versa. Now it's time to figure out how I'll determine the composition of the Drifting Amalgams planets. Until next time, stay curious.